Solutions, General Chemistry Exam, Fall 2021. Okay, so we're gonna go ahead and go through the test. Identify the trend for question number 1 that you see on the graph to the left. Okay, so if you did your graphs on your notes, all you had to do for this one was just basically take a look at the 3 graphs, figure out which one this was. And if you have them in there, you should have figured out that this is atomic radius versus atomic number. Okay, that's all you had to do for this question. All right. Next question says, label both axes of the graph and identify the peaks and the valleys with the element names. All right, so then if you just label on the graph here, this is your atomic number down here. Okay, this is your atomic radius. That's all you had to do here. And then circle the peaks. So here are the peaks that we see. Okay, and if we're looking at that, all you have to do is put the chemical symbol. So this is hydrogen. Okay, this one is lithium. Right, this one is sodium, potassium, right, and rubidium. The valleys, if you just did these 3, I'm okay with that. I'm gonna do it a different color. So it's here, 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 and here. So this one right here would be helium. This is neon, this is argon, and this is krypton. Okay, that's basically all you have to do for question number 2. And you would have got full credit. Okay, for the questions, these are worth 1 point, this is worth 1 point, this is worth 4, and this is worth 4. Okay, explain the trend that you see represented here and justify the pattern. Pick any period to explain. Okay, so this is atomic radius. Okay, so what we're looking at here is we're looking at the radius of a single of the atoms period by period. So if I go here, I can see that lithium is the start of the second period and neon is the start of the end of the second period. It says pick any period to explain. So all you had to do to receive full credit for this question was tell me that from lithium to neon, okay, we see a steady decrease on the radius of an atom. Now, remember that the radius of an atom is the distance from the nucleus to the edge of the electron cloud. So as we add more and more protons to the nucleus of the atom, the pull on the electrons becomes stronger and it pulls that radius tighter. So as you go from lithium, for example, let's see, you have a radius here, and you add more and more protons, what's happening is the electron cloud begins to shrink. And what it does is it pulls in all those electrons closer to it. So the radius from lithium to neon is smaller, right? Now, you need to write that, right? I'm not going to do it here because I want to make this video short for you guys, but basically if you would have written something along those lines, you would have gotten all full 4 points for this question, okay? Explaining that the trend decreases from the start of the period to the end and the reason why. 1C says, provide a general statement about the trend you see and how it increases, decreases across the periodic table. Well, here from lithium to sodium to potassium to rubidium, what we're doing is we're going down the periodic table, right? So we have lithium, sodium, potassium, and rubidium, right? These are all elements in group 1. So as you go down the periodic table, right? As you go down the periodic table, then the atomic radius, which I'm going to abbreviate AR, is decreasing, right? And we just explained that as you go from the start of the period to the end of the period, sorry, not decreasing, increasing. See, because it's going in an upwards trend. That was my fault, excuse me. So it's increasing. I was getting ahead of myself. All right. What we just explained here, though, is when you go from the start of a period to the end of the period, we see that there is a steady decrease in the atomic radius. So the general statement that you would have been able to put here, right, and you guys should be writing this down, is that the atomic radius decreases from left to right, across a period, and increases from the top down of the periodic table down a group. Okay, the reason for the increase down the group is because every new period adds a new electron cloud. And as you go from left to right, what's happening is the protons are pulling in the electrons just a little bit closer. okay? So if you had something like that, then you got the question full credit. If you did not have something like that, depending on what you wrote, will get you, you know, certain amount of points. Number 2, it says, explain first ionization energy of an atom. Okay, the ionization energy is the energy required to pull away an electron. So let me see if I can put a little text box here. Okay, so the energy required to remove an electron, well, a valence electron from the electron cloud. Right? So it's got to be the outermost electron. I'm going to make this a little bit smaller here. Spell check this. And then I'm going to put this in place here. So something along these lines, if you would have put something along these lines, you would have got the full credit for this question. This question is worth 2 points. Whoops. This question is worth 2 points. This one is worth 4. This one is worth 4. Okay. So to the right here, we see the trend of first ionization energy. What happens to the ionization energy at the start of the period towards the end? Okay, so again, here we have helium. Here, I mean hydrogen. Here we have helium. And then the next period, we have lithium, right? And then the last element here is neon. So from the start of the period on the periodic table, which is lithium, which is period 2, right? I'm going to label this here, period 2. Okay, remember, this is stuff that you have to write, but I'm just telling you guys, okay, because I don't, like I said, I'm trying to keep the video short. So this is stuff that you should have written down on your test. To the right, we see the trend, ionization energy. So here's the start of the period, lithium. Here's the end of the period. As we can see, as we go from the start of the period to the end of the period, we see an increase in ionization energy, okay? So basically, to get full credit for these points is all you had to say was, well, from the start of the period lithium to the end of the period neon, we see a steady increase in the amount of ionization energy. The ionization energy is not consistently going up. We do see changes here, right? But the overall trend is that it increases across the period. So from left to right on the periodic table, you see an increase in ionization energy. Okay. 2b, it says, on the graph, circle the following elements: beryllium, boron, nitrogen, and oxygen. Okay. So here, 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 here. And it's asking you the question that I just kind of asked a little bit ago. It says, why does you see a slight drop in the ionization energy? This question, basically what happens here is here's what's going on, right? This is how you could have explained it, because what I wanted you guys to do here was tell me why we see a decrease, and we discussed this in class. Okay, let's take a look at oxygen and nitrogen. Okay, so I'm going to give you this is 2s, this is 2p, this is for oxygen or nitrogen, and then this is the 2s, this is the 2p. Look at the configuration here. Okay, so this is 1, 2, 1, 2, 3. That's nitrogen. 1, 2, 1, 2, 3, 4. And this is oxygen. Okay, so this is the electron configurations of these two elements. Here's what's going on. Take a look at nitrogen and oxygen. Okay, and I want you to tell me what the difference is. Which one looks a little bit more balanced to you? Okay. Nitrogen, you can see here, has 1 electron in every subshell in the 2p. And oxygen has 1 electron in the subshell in the 2p, but it has this extra one right here. You see that extra one right there? So what happens with oxygen and nitrogen is when you get to nitrogen, it's like, oh, hey, look, I'm filled up. You know, I'm not completely full, but at least I have a nice balance set up with my electrons. When you get to oxygen, you get that 1 extra one. So think of it like a scale. Right? So now the scales are kind of tipped in this direction here, going this way, and it's kind of throwing everything out of balance. So what the atom does to kind of keep everything nice and balanced and symmetrical, it's not going to fight to keep this electron very much, right? It's not going to fight to keep that electron very much. So it's going to have a slightly lower ionization energy than it would if it were nitrogen. Doesn't mean it's going to let it go, but it's just not going to fight as hard to keep that electron. So that's why you see the drops here. And that's why you see the drops here. okay? Something along those lines would have given you full credit, but I just wanted to see where you guys were at with this. So it's not one of those that's going to really hurt you if you guys didn't get there. I just wanted to see what your thought process was, okay? So think of that kind of like a bonus question. Number 3, identify the element we see here. Okay, so by now you should know how to do your ionization energy, your electron configuration. The little trick that I do is I just kind of like ignore all this stuff over here, right? I ignore all this and then just look at this one. Okay, so I'm going to go to the 5s2. Okay, so that's in the 5th period. And then the 4d9, that's going to give me 9 electrons in the D block. You should have ended up at silver. You should have ended up at silver. Okay, it says explain the ionization of this atom. What type of ion does it form and provide the oxidation state? Well, we know that silver is a transition metal. So you should know that this guy is going to oxidize. Okay, and because you have a reference chart in your periodic table and your notes, you should have known that this guy forms a +1 cat ion, +1 cat ion. That's what I was looking for in this question. And again, you have a reference table in your notes that would have given you this answer. So what kind does this form? This forms a cation. Okay, it forms silver 1+. What compound would form if this ion bonded with a phosphide ion? Make sure you show your work and provide the final compound, the correct format. So on that same reference table, the periodic table of ions, you should see that silver makes a 1+, and phosphide ion is an ion that forms a 3-. Okay, to get full credit for this question, all you have to do is provide the compound, and to do that, you do it one of 2 ways. Right here, you can add these together, and you can see that it does not equal 0. So you can multiply this guy by 3, multiply this guy by 1, and you end up with Ag3. Sorry, let me erase that. P1, you don't have to write the 1, so it looks just like this. Or you could have just said, hey, mister, I know that if I take my charges and I bring this number over here, and I bring this number over here, see how it forms like a little fish right here? That's why we call it the fish. I get the compound Ag3P. And that's all you needed to do to get full credit for this question. Okay, I want to make sure you guys are putting these notes in your notebook. I'm going to create an assignment on Google Class. Make sure to submit it, and we'll talk about what this does for your grade. Okay. All right, guys, that's pretty much it.